Let's define piecewise linear functions. Piecewise linear functions are those graphs who consist straight line segments. What does segments means? That for the portions of their domains, if suppose we have some set of domains, the graph is defined differently on different portions of the functions. So suppose on the one small portion, function will be defined differently. Under the function part, the function will be defined differently. Let's learn it using an example. So here we have this function f of x is equal to x plus 1 if x is less than or equal to 2, and the function is defined as minus 2x plus 7 if x is more than 2. So what does that mean? That means, say we have x-axis here, this is our y-axis, there is 2 here somewhere. Before 2 and at 2, the function is defined as x plus 1, and after 2, function is defined as negative 2x plus 7. So that means for graphing the function, we have to use different equations for less than or equal to 2 and for more than 2. Let's see how that is. The first part of the function f of x, which will give us y obviously, is equal to x plus 1 provided x is less than or equal to 2. So let's draw that part. So for that, how do you graph it? We always have to draw a table of values x and y. So x can take any real numbers, we know that. But in this case, we have to take x's value less than or equal to 2. So at 0, y will be 0 plus 1, that is 1. At 1, y will be 1 plus 1, that will be 2. At 2, y value will be 2 plus 1, that is 3. We cannot take x value to be 3. Why? Because x has to be less than or equal to 2. Let's plot these points. At 0, let's see, this is 1, 2, 3, and so this is 1, 3, 4, so on. So at 0, we have 1. At 1, we have 2. At 2, we have y value to be 3. That's it. So our graph of this segment of your function is this straight line. It's linear function, so it has to be straight line. It keeps on going towards left. We can take negative 1 value and also negative 2 and so on. That's why there is an arrow in this side, because it keeps on going. But there is no arrow here. It stops right here at 2. And this is a solid point. Why is it a solid point? Because there is an equality here. X is less than or equal to 2. Let's see. Now the remaining segment of your function f of x is negative 2x plus 7 if x is more than 2. Let's draw the table of values for that. If x is more than 2. So naturally we have to take value 3. So if you take x value 3, that will be negative 6 plus 7, that is 1. But I want to know what happens at 2. Just, I know we cannot take 2 because there is no equality sign. I'll tell you in a second. But I want to know what happens at 2. Negative 2 times 2 plus 7, that gives me 3. And one more value let's try to find, say at 4. Negative 4 times 2 is negative 8 plus 7, that's negative 1. So let's plot these points. At 3 it is 1. At 4 it is negative 1, somewhere here. So if I join these points, my line goes somewhere like that, right? Straight line. This has to be a straight line which is going this way. Now I found at 2 this is 3. That is the same point here. That means this graph continues until here, because for every point between 2 to 3 this graph holds. Only at 2 this doesn't hold, right? Every point above 2 this line holds. but because these 2 points coincide at the same point, so we can join these lines like that. Okay, so this is the graph of the given piecewise function. It's defined differently for the values of x less than 2 and different another way after 2. Let's take another example. So we have our function called absolute value function in example 3. What is absolute value function? This is absolute value of x. That means it just gives you the value, not the sign. And if you remember in section 3.1, we defined it as a piecewise defined function. So absolute value function of x gives us same x if x is more than or equal to 0. It gives us negative x if x is less than 0. Why? What does negative do? If the value is negative, it makes another negative to make it positive, right? Because we only want value in absolute value function. So let's see. If we have to draw the table of values, then when x is positive, then y is equal to absolute value x is equal to just x, right? So if x is there and y at 0, it is 0, at 1, it's 1, at 2, it is 2. So the same values are coming. But if x is less than 0 and those points, your y will be, which is absolute value function, will become negative x. Let's see how. So at negative 1, because we only have to take values which is less than 0, y value is 1. At negative 2, it's 2. At negative 3, it's 3. And I know we cannot find 0, but we just want to know what happens. So at 0, it is be 0. Let's plot the graph now. We have our x-axis and we have our y-axis. At 0, absolute value of the function is 0. 1, 2, 3. At 1, it is 1. At 2, the absolute value is 2. At 3, the absolute value is 3. So join them and that is your straight line. So you can, that is one segment of your function, that because I told absolute value function is a piecewise defined function. At negative 1, it is 1. At negative 2, it is 2. And at negative 3, it's 3. You connect them. So absolute value function's graph is a V graph. It looks like that. It's symmetric with respect to y-axis and the corner of the V comes at origin.